Hello guys, in this video we're going to be talking about the law of cosines, and the learning objectives for this section is to use the law of cosines to solve oblique triangles, solve applied problems using the law of cosines, and use Heron's formula to find the area of a triangle. Now, why do we need another law? Let's take a look. So here's an example. We have a boat that left port going north for 10 miles, and then it turns 20 degrees to the east and travels 8 more miles. So the question is, how far is the boat from the port? So in this case, it would be easy to find this angle right here. It's 180 minus 20, so that's going to be 160. But the problem is that this angle is between the two known sides. So we don't know any of the angles across from those known sides. And the angle that we do know, it's across from the unknown side. So we cannot apply the law of sines. And that happens when we have this situation, when the angle is between the known sides, known as SAS, or side angle side, or when we know all of the sides and we don't know any angles, known as SSS, abbreviated, or side, side, side. All right, so in order to deal with those kind of situations, we need to learn the law of cosines. Here it is. This is the law of cosines. Again, we have a triangle labeled the way that we discussed in a previous section. And so the law of cosine says that a squared equals b squared plus c squared minus 2bc multiplied by cosine alpha. And you know that we have two more formulas that are symmetric. Once you know one, you know them all. And also on the right hand side here, we have these same formulas, only solved for cosine function, but otherwise they are the same, so you don't have to memorize them separately. Now, how did we come up with these formulas? Let's take a look. We're gonna derive those formulas here in a minute. In order to come up with a law of cosines, we're gonna look at a generalized triangle. Usually triangles, they exist anywhere, but we're gonna put our triangle on a coordinate system with one of the vertices A at the origin. Okay, and the axes going through one side of the triangle. Okay, let's take a look. It's a generalized triangle. So this hypotenuse of this triangle is not necessarily 1, right? So it's not a unit triangle, or it's not a triangle in the unit circle. So the x and y coordinates here are scaled by the length of this side of the triangle. If you're wondering why, then look at my other video about similar triangles. You'll understand why. But anyway, so this right here, this is our x coordinate of this vertex C. And this is our y coordinate of that vertex C. Now, we're going to be focusing on this triangle right here. CB, well, let's call this point D. So we're focusing on the triangle CBD. And as you can tell, this is a right triangle. We know how to deal with right triangles. This line is perpendicular. Now let's take a look at the length of the sides in this in this smaller triangle. So okay, this side is the same as the y coordinate, right? Now what about this side of the triangle? This whole thing is x, right? Now this side and I forgot to mention that these sides are known, right? So um, this side is c. This means that this one piece is x minus c. So this side of the smaller triangle is x minus c. So using Pythagorean theorem, we can write that the diagonal square, or a squared, equals the sum of the square of the legs. So basically we have y squared plus, what is this, x minus c squared. All right, so now instead of x and y, I'm going to put in our expressions b sine theta and b cosine theta. So a squared equals y is b sine squared. Okay, and then plus x is b cosine minus c squared. And so now, oh, sorry, this square is outside. It's not here yet. Okay, so now I'm gonna open up these squares, and I need a little more room for that. So, okay, so this is a monomial squared, okay? We have two factors, b times something else, and both of them get squared. So we get b squared multiplied by sine squared theta. Now this is a binomial. It's the x minus y squared situation. So we're going to apply our square the binomial formula, which will give us a trinomial. Again, if you don't remember it, go ahead and review it. So which basically gives us the square of the first term. So that's b squared cosine squared theta minus 2 times the first term, b cosine, by the way, this is theta, and plus the square of the second term. Okay, but it's 2 times the first times the second, so we have to multiply by c as well. I'm gonna insert it in here because I ran out of room. Okay, so what I'm gonna do now, I'm gonna actually combine. I'm gonna combine b squared sine squared and b squared cosine squared. I'm gonna factor out b from here. So I'm gonna have b squared sine squared theta plus cosine squared theta. What else do I have? I have minus 2 bc cosine theta plus c squared. Now this, if you recognize it as Pythagorean identity, this is a 1. So what do we have? We have b squared minus 2 bc cosine theta plus c squared, and that's our law of cosines. I'm gonna copy it with the a squared on the left side, and also I'm gonna move the c over. So a squared equals b squared plus c squared minus 2bc times cosine theta. Okay, and this is our law of cosines. And in a similar manner, we can figure out, the law of cosines for b squared and for c squared. They're going to be similar. So that's the derivation. Let's see how to apply it.